Now that we've seen how to declare a function pointer, let's see how we actually go about using one. Let's use our example from the previous module. Remember this function pointer, we should be getting used to the sight of it by now. We could assign this particular function pointer to point to reademp. Remember reademp, which was going to read in a single employee, as follows. It's very, very simple. That bit of code is simple code. The declaration is difficult, but the assignment is easy. In fact, the assignment is a little bit confusing. You might think, well, a function pointer is supposed to store the address of a function. Now, where is the address of operator here? Surely it should be ampersand reademp. Well, it's simply not. No ampersand is required. When you state a function like I stated reademp there, reademp, you don't need to put an address on the address operator on the front of it because it's already treated as the address of that function. Okay. It is extremely important that you understand the difference between the following lines of code. That is the assignment statement that we saw in the previous slide. And this is very different. Notice the two brackets at the end, that's the only difference. This does something completely different. The first line takes a function pointer and assigns to it the address of a function. The second one actually runs the function, or at least it attempts to run the function. The function is supposed to take a parameter, and we're not passing it a parameter, so there's obviously going to get some error message there. But we're attempting to run the function, and whatever that function returns as its return type, we're trying to put that into function pointer. In other words, we're trying to take the return value of the function and assign that to function pointer. Now that is clearly wrong. Well, it's clearly wrong in this case. You must not get those two confused. I see people do this all the time. The compiler doesn't allow them to do it. You get all sorts of error messages, but they try and do it, and they don't understand why it's not working. Okay, now that we've cleared that up, we've got a function pointer that has been successfully initialized. We still haven't done anything with it. All we've done is we've assigned it to a value, assigned it to a particular address of a function. How do we actually use it? Well, once we've initialized func pointer, and there's our initialization statement again, we can call the function reademp via function pointer. In other words, we can cause the function reademp to be run without ever actually putting the word reademp in our code from that point onwards. And this is how you do it. Let's say we had an employee structure called E. We can simply call our function pointer as if it was a real function, and as if it was an actual function, and we could pass it a parameter, which would, in this case would be the address of the employee. In other words, we could treat function pointer as if it were really reademp. In other words, we've made an alias for reademp called function pointer. So that's how you use a function pointer. Now, I expect that a lot of that is very, very confusing for you. It certainly was confusing to me the first time I saw it. So let's go and have a look at two very distinct coding examples. This is funcpointers.c. Let's have a look at what we've got. We have got a function called add here, and we've got another function called subtract, and they're almost exactly the same. They both have this specification. They return an integer, and they take two integer parameters. Each one of them is the same. They obviously do slightly different things, but their prototypes are the same. Now, what I'm going to do here in main is I'm going to ask the user to enter two numbers, ask them if they would like to add or subtract, and they'll either enter an A or an S. And then I'm going to get the result of the numbers and the operation that they asked for, and print the result. Now, I want to do that with only one line of code in the entire program that looks like that. Result equals something. I don't want to say if they're adding, then do this, else do that. If they're adding, then result equals this, else result equals that. I only want to have one result equals line on my entire program. So, how do I do it? Well, first, I have to declare a function pointer. So let's do that. It's a function pointer is going to point to one of these two functions. So in other words, it has to be very, very similar to each of these declarations. So what I'll do is I'll actually copy and paste that definition down to here and get rid of the word static because we don't need this to be a static variable. And now what are we going to call it? We'll call it func pointer, like that. I'll put a semicolon on the end of it. Now, this isn't quite complete. I have to make sure it's a pointer by putting that asterisk in there, the star in there. Okay, now just so that you know, it doesn't actually matter whether we put the A and the B there. As long as we say that it takes 2 integer parameters, that's all we care about. This one could be called X and Y, just so long as it will actually compile and run, and that's okay. They don't have to have the same parameter names, but they do have to have the same parameter types, and they have to have the same return type as well. Okay, so that is a function pointer that will point to, theoretically, one of these two functions. So let's see now what we do. We can say, in fact we don't need this boolean, we can just get rid of it. We can simply say if the getChar equals A, then, and this is how we write it, func pointer equals add. Now add, if you recall, is the name of this function. There's add right there. So func pointer equals add. And I can say else func pointer equals subtract. Okay, so now I've initialized the function pointer. Now I'm actually going to use the function pointer as follows. Func pointer, open brackets. I'm putting brackets now on the end of a variable name, and that's okay if that variable is a function pointer. And I'm going to pass it 2 parameters. In other words, these ones, X and Y. And I'm going to pass it X first and then Y. And then print out the result. Now notice that X and Y have got nothing to do with this X and Y. That's just a coincidence. If we really want to be pedantic, we can call this I and J, just to make sure that they are completely different. I and J. Okay, now, will this compile? It's a very good question. It probably would compile if I made sure that was a J and an I. So let's give it a go. Compile. No errors. Okay, so everything I wrote was legal code. Let's try and run it now. Please enter the first number, 12, and the second number, 3. Would you like to add or subtract? Well, let's try add first. The result is 15. Now, isn't that magical? And we'll run it again, and this time we'll do the subtract. 12 and 3, and we'll subtract this time. The result is 9. That's great, isn't it? So let's look at what's really going on here. We're basically saying, which function do you want to call to get the result that you want? That function or that function? And then you simply call that function. That will make a direct call to add or subtract, passing in the values I and J. That's what will happen. I guess you could call that the classic use of function pointers. Very simple. Well, that's about as simple as function pointers ever get. Why do you think this is the last chapter in the entire course? Okay, let's look at another example. This one involves a function out of the standard C library called qsort. Okay, this is qsort.c, and I guess this is probably the first true useful example of function pointers, the first bit of really generic code that we're taking advantage of here. However, we're not defining the function pointer, the standard C library is. Let me show you what I'm talking about. Right down at the end of the function, we've got our main, and we've got a series of employees. There's our 5 employees. And what we want to do is we want to sort them. We want to sort them, I don't know, by age, or by salary, or by surname, or we haven't got a surname, by first name, or whatever. We want to sort them in some way. There exists a function in the standard C library called qsort. This is qsort right here. Qsort is a program that will sort anything for us. It will sort employees, it will sort integers, it will sort arrays of characters, it will sort absolutely anything that you tell it to sort. How does it do that? In other words, qsort is a completely generic function. That's what I mean by generic. It will work with anything. It's reusable. Generic, reusable. These are words I want to start introducing into your programming language. I'd like every piece of code that you ever write to be generic and reusable. You know, that's not going to happen, but it's a nice ideal. Anyway, qsort takes 4 parameters. It takes the array that you're trying to sort. It takes the number of elements in the array. It takes the size of each element. It's obviously going to multiply them together to know how big the actual array is. And then, and here's the clever part, it takes a function. This is a function. This is the name of a function. It takes the name of a function and it's going to use that function to perform the sorting. Now you have to provide that function. If you're going to ask qsort to sort something, you have to tell it how to sort. Do you want it sorted on age or salary or name or address? How do you want it sorted? You actually have to specify that, and you specify that by passing in a function. And the function is very similar to string compare. Remember, string compare will compare two strings and it will return a value that's less than 0, equal to 0, or greater than 0. Well, you have to write one that's almost exactly the same. Your function is going to return less than 0, equal to 0, or greater than 0, depending on whether two parameters that are passed to it are less than, greater than, or equal to each other. And qsort will use that function that you pass it to determine the sorting sequence of these employees in this case. Finally, when they're sorted, we're just going to simply print them out in their new sorted order. In other words, qsort actually does change the sequence of the employees in the array. It will reorganize the array for you. It will rewrite the array. But we are okay with that. So this is going to print out the details. Okay, so let's go now and have a look at this compare ages. I've already written compare ages for you, so I can show it to you. Compare ages is here. Now, compare ages takes 2 parameters. How do we know that? Well, because it's part of the definition of the 4th parameter of qsort. If you go into your standard library reference, your standard C library reference, and look up qsort, you'll find the specification for the 4th parameter. It must be a function that returns an integer and takes 2 pointer parameters, void pointer parameters. So that's what we've written. I've written a function here that returns an integer and takes 2 void parameters. And each of those void parameters is going to be considered to be a pointer to an employee. It will be. So this is how I do it. This is how I use a void pointer. You haven't seen this before. Here is my void pointer number 1. I'm just going to simply assign that to employee pointer number 1. Don't worry about that little const there. That's a requirement because all function prototypes of qsort have to have 2 const parameters. Now, I haven't explained the const keyword yet, and I'm not going to because it's not hugely important. It's just that you need to have it there. It simply means that the function compare ages cannot change the contents of either of those pointers. And we're not going to. We're just going to compare them. Okay, so don't worry about the word const scattered around there. That's just a requirement of using qsort. At least it's a requirement of using this particular version of qsort. Your version may actually be different to this. Anyway, that's not the important thing. The important thing is I'm declaring 2 temporary variables, E1 and E2, which are going to simply represent the addresses V1 and V2. Once I've got those declared and assigned, then I can simply say, well, if I subtract the ages, then I'm going to get a number that's either less than 0, equal to 0, or greater than 0, depending on whether E1 is greater than, equal to, or less than E2's age. Now, I know that's a little bit of trickery, but I'm sure you can figure that out for yourselves. In fact, I could have written the entire function with 1 line of code, just like that. I could have put return all of that. I'll just put the word return in there, and a semicolon on the end, like that. Now, that would have worked just as nicely, but it's less clear. You've got some horrible casting going on here. I'm taking the V1 pointer and I'm casting it to an employee pointer. And then I'm taking the age of that, of the result. And now, that's okay to do that, but not for learning purposes. For learning purposes, it's much easier to simply just declare 2 new temporary variables that are both employees. Anyway, qsort is going to call this function. We're never going to call this function directly. qsort will call it every time it needs to compare 2 of the elements in our array to see if one is greater than the other. Okay, so let's compile and see if that works. We compile, Run. Okay, now theoretically this output is supposed to be sorted by age, and it is 1245. We've got two 45s, so it doesn't matter which order they come in. Then we've got a 51, and then we've got a 99. So they are indeed sorted by age. And for the absolute proof, we'll go to the end of our program here, and we'll see that the original array was not sorted by age. We had 45, 99, 12, 45, 51. It was not sorted by age. Okay, so what I'll do now is I'll write another function that sorts them by first name. And then I'll print them all out again, this time sorted by first name. Okay, let's have a look at that. I'm just simply going to have to write another comparison function here. And this one I'll call compare names. And again, it takes two parameters, exactly the same. That's the thing about these function pointers, or at least the functions that they point to. The functions they point to are always going to be very, very similar. Anyway, this can stay the same, those two temporary pointers. And all I'm going to do now is I'm going to return strucump. I'm going to pass these two names into strucump and let strucump compare them for us. So it's a bit of cheating. And that's the completed comparison function for names. So now I can go down here and I can print them all out again, or I can do another QSort and another set of printing. And this time I'll call the function compare names. I think it was plural. And let's see if we can make the output look the same. No, that's just going to say Fred is named Fred, so that's a bit silly. We'll just call it. We'll just have Fred like that. Okay, so we do another QSort. We sort the list a second time, and this time we sort it by name, and then we print out all the 5 names. Okay, so let's have a go at that. Compile. No errors? No errors. Gosh, so easy, isn't it, this stuff? Now, this should be alphabetical. B, F, M, S, T. That is now in the correct order. B, F, M, S, T. And it was not in the correct order here. M, S, D, F, T, like that. So that is definitely now sorted by name. Okay, so what we've got here is a truly generic piece of code. We've got a piece of code that can compare, can sort for us, can sort anything. Can sort integers, can sort floats, can sort employees, can sort CDs. All we have to do is write the appropriate comparison function. We need to write an integer comparison function if we wanted to sort an array of integers. Now, whoever wrote QSort, I've got to take my hat off to them because they did a good job. They've written a beautiful piece of generic reusable code, which is exactly what libraries are supposed to contain. They're supposed to contain reusable code. So what I'm suggesting is that you write reusable code whenever you can, rather than restricting yourself to just deal with CDs or just deal with bananas or whatever it is your program happens to work with. See if you can rewrite the functions that you're writing in such a way that they'll work with anything. And if they work with anything, you can stick them in a library and use them for your next project, which means it's going to take half the amount of time to write your next project as it did to write your project if you didn't use reusable code. Let's go and have some quick words now on generic code. That'll be the next module.